Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science, please. Everything is theoretically impossible until it is done. Today's topic is work and energy. In this video, we are going to learn about what is work, types of work, energy, potential and kinetic energy, conservation of energy, and power. Work. When a force acts on an object and the object shows displacement in the direction of the force, work is said to be done. As you can see in the picture, work is equals to force into displacement. Can be written as W is equals to F into S. For doing work, energy is required. In animals, energy is supplied by the food they eat. In machines, energy is supplied by the fuel. Reading, writing, thinking, etc. are all energy consuming, but in scientific manner, no work is done in these cases. Work is said to be done when a moving object comes to rest, an object at rest starts moving, velocity of an object changes, or the shape of the object changes. As you can see the picture, there is a change in position and displacement when a man pushed a box from location A to B, or when a crane tows a broken car and takes it to the workshop. There is displacement in the object. Or when there is a change in speed or direction, like when a boy hits a ball to dodge another player, or a batsman hitting a ball during a cricket match. Or when there is change in shape or size of the object, like a compressed spring when released does work on the ball. Conditions for work done are: forces should be applied on the body, body should be displaced, work is a scalar quantity. Unit of work. Unit of work is Newton meter or joule. As you can see, W is equals to F into S. 1 joule is equals to 1 Newton into 1 meter. The amount of work done depends upon the magnitude of force. That is, the greater the force, greater is the amount of work done, and vice versa. And displacement. Greater the displacement, greater is the amount of work done, and vice versa. Work done by the force can be positive, negative, or zero. Positive work. Work done is positive when the force acts in the direction of the motion of the body. As you can see in the picture, the force is acting and the displacement takes place in the direction of the force. Negative work. Work done is negative when the force acts opposite to the direction of the motion of the body. As you can see in the picture, the force is acting on the opposite side and displacement is taking place on the opposite side. The force is the friction force. Zero work. Work is zero when force acts at the right angle to the direction of the motion of the body. As you can see in the picture, the force is in the upward direction and the displacement is on the perpendicular direction of the force. Energy. The capacity of doing work is known as energy. The amount of energy possessed by a body is equals to the amount of work it can do. Working body loses energy, body on which work is done gains energy. Energy is a scalar quantity And unit of energy is same as that of the work, that is joule or Newton meter. Forms of energy. There are many different kinds of energy. We are going to study mechanical energy. It is the energy possessed by a body on the account of its motion or position. Mechanical energy is the sum of kinetic energy and potential energy of the body. Kinetic energy. The energy of the body due to its motion is called kinetic energy. As you can see the examples: aeroplane flying, cycling, car moving, windmill rotating, boy skating, boy kicking a ball. As the speed of an object increases, kinetic energy also increases. Formula for kinetic energy. We know that work is equals to force into displacement. Also we know that force is mass into acceleration. So according to third equation of motion, we know that v square minus u square is equals to 2as. So from that we find out that s is equals to v square minus u square upon 2a. Now substituting the equations of 2 and 3 in equation 1, we get work is equals to m into a into v square minus u square upon 2a. Solving this equation, we get half m v square minus u square. Since the initial velocity u is 0, we can write that the kinetic energy is half mv square. This is the formula for work done or kinetic energy. Hence we can say that kinetic energy is directly proportional to the mass and the square of velocity. Potential energy. The energy of the body due to its position or change in shape is called potential energy. As you can see the example: raised object, dynamite, stretch spring, batteries, drawing the bow. Potential energy is directly proportional to mass. So more the mass of the body, greater is the potential energy, and vice versa. Potential energy is also directly proportional to the height, which does not depend on the path it follows. So greater the height above the ground, greater is the potential energy, and vice versa. Third is change in shape. Greater is the stretching, twisting or bending, more is the potential energy. Potential energy of an object on a height. If a body of mass m is raised to a height h above the surface of the earth, the gravitational pull of the earth m into g acts in the downward direction. To lift the body, we have to work against the force of gravity. So we know that work is equals to force into displacement, and force is mass into acceleration due to gravity. So m in force will be m into g, and the displacement here is the height h. So we can write work done is equals to m into g into h. Thus potential energy is mgh. Transformation of energy. The change of one form of energy to another form of energy is known as transformation of energy. For example, a stone on a certain height has entire potential energy, but when it starts moving downwards, potential energy of the stone goes on decreasing as the height goes on decreasing, and its kinetic energy goes on increasing as the velocity increases. At the time the stone reaches the ground, potential energy becomes 0 and kinetic energy is maximum. So as you can see in the picture, the first picture shows when the ball is at rest, potential energy is maximum and kinetic energy is 0. But when it starts falling, kinetic energy increases and potential energy decreases. And when it about to reach the ground, kinetic energy is maximum and potential energy is 0. Law of conservation of energy. Law of conservation of energy states that energy can either be created neither be created nor be destroyed, but can be transferred from one form to another. The total energy before and after the transformation remains constant. Total energy is equals to kinetic energy and potential energy. So half mv square plus mgl is constant. Whenever energy changes from one form to another, the total amount of energy remains constant. So you can see the examples of how one form of energy is converted into another form. Power. The rate of doing work or the rate of transfer of energy is called power. In other words, we can say that power is defined as the rate of energy consumption. It is denoted by P. So power is equals to work done upon time taken. That is P is equals to W upon T. The SI unit of power is watt or joule per second. Commercial unit of power is kilowatt, that is the energy used in 1 hour at 1000 joules per second. Thanks for watching. Please do like, share and subscribe.